All right. So we forge ahead. The next question, number 10, right? The first law of thermodynamics is option A, the law of conservation of energy. Option B, the law of conservation of mass. Option C, the law of conservation of momentum. Option D, both A and B. Now, you have to be careful in solving or answering questions like this. Now, the law, the first law of thermodynamics is one of the laws of thermodynamics. We have several laws of thermodynamics. We have the zeroth law of thermodynamics. We have the first law of thermodynamics. We have the second law of thermodynamics. I think we have the third law, of thermodynamics. But this question requires of us the first law of thermodynamics. The first law of thermodynamics states that energy can neither be created nor destroyed in a chemical process or in any process at all. However, can be transformed from one form to another. Energy can neither be created nor destroyed, but can be transformed from one form of energy to another. See, this first law is also known as the law of equivalence of all forms of energy. Now, but one thing you should know that energy and mass are interconvertible. Mass can be converted to energy, energy can be converted to mass. Now, remember the famous Einstein equation, E is equal to mc squared. E is equal to mc squared. Energy equates mass, mass equates energy. So, both option A and option B are practically what? Correct. So, the first law of thermodynamics is the law of conservation of energy, is also the law of conservation of mass. So, the answer is option D. Clear? All right. So we move to the next question, which is question number 11. Question number 11. Question number 11 is the internal energy of a system does not depend on option A, transition energy, option B, vibration energy, option C, energy due to gravity, option D, rotational energy. All right, so before we answer this question, I hope you still with your writing material, so you should be penning down these questions. They are live questions that you may see in any chemistry exam. Now, the internal energy of a system does not depend on, first of all, what is internal energy? Now, internal energy is the energy contained within a system. So, internal energy is the energy stored within a system. Now, the absolute amount of internal energy cannot be determined. Absolute internal energy of a system cannot be determined. However, we regard it as the sum of all the different forms of energy in a system. I repeat, internal energy is the energy stored within a system. Absolute internal energy of a system cannot be determined. However, it is regarded as the sum of all the different forms of energy in that system. So, in a nutshell, my internal energy, which is represented with capital letter E or U in energetics or thermodynamics, is equal to the sum of different energies in that system. It can be the sum of the transition energy to that of the vibration energy to that of the rotational energy to that of the nuclear energy to that of kinetic energy to as many of the different forms of energy in that system. Now, recall that we said that internal energy is the energy stored within. It's not the energy on the system. It's the energy within the system. So this brings us to answering this question with ease. So it depends on transition energy. It depends on vibration energy. It depends on rotation energy. However, it does not depend on energy due to gravity. So the answer is this. Just chill. We have a lot of questions that once we are done with this, you can answer any energetic question or thermodynamic question with ease. So you don't just read, you have to practice questions. Once you practice questions, you become master of that particular topic. So we forge ahead. Question number 12. Question number 12. Two fundamental ways to transfer energy are option A, pressure, and temperature. Option B, pressure and volume. Option C, heat and work. Option D, heat and volume. So we have that question on the board. Now, the question is two fundamental ways to transfer energies are. Now, first of all, you should know that the answer is not pressure and temperature. The answer is not pressure and volume. The answer is not heat and volume. The answer is heat and work. Energy is transferred in and out of a system in two ways, two fundamental ways, as heat and as what? Work. Now, if this is a system, if this is a system, now energy will enter this system in two major fundamental ways. Energy will enter in form of heat, can also live in form of heat. Energy can enter in form of work, energy can also leave in form of work. However, now we can have positive Q and negative Q. Same, we have positive W and negative W. So this is positive when heat flows into the system. Now it is Q is negative when heat flows out of the system. Now Q is positive when work is done on the system. Now, W rather. W is negative when work is done by the system. I repeat, Q is positive when heat flows into the system. Q is negative when heat flows out of the system. W is positive when work is done on the system. W is negative when work is done by the system. So we are going to write again. I'm going to give you the sign convention. Sign convention. Good. Now, positive Q is heat flows into system. Negative Q means heat flow out the system. Positive W means work done on system. Negative W, work done by system. So take note of this. Now, there's a relationship between internal energy, heat flow, and work done. Now, internal energy U is equal to Q plus W. So internal energy is equal to Q, which is heat flow, plus W, which is work done. So once we note this, you can be asked what's the relationship between internal energy, heat flow, and work done. Now, if Q is equal to 0, internal energy U depends on only work done. Now, for positive work done on the system, internal energy will increase. Now, for negative work done by the system, internal energy will decrease. I told you if the heat flow is 0, internal energy only depends on work done. Positive work done on the system, internal energy will increase. Negative work done by the system, internal energy will decrease. Also, if W, which is work done, is equal to 0, internal energy will not depend on only heat flow. Now, positive heat flow, that means heat flow into the system, will increase internal energy. Negative heat flow, that means heat flowing out of the system, will decrease what? Internal energy. So I hope this is very useful. So I'll give you time to write this. So pause